When we're solving equations where we've got a denominator underneath the whole thing, or whole side, like we have here in these two examples, the easiest way to think about this is if we imagine this whole numerator as being one single number. So maybe that is a y over 2 equal to 5. So I'm just replacing the x plus 3 and considering it just a y, pretending for right now it's just that one single letter y. How would I solve this problem? Well, it's dividing by 2 using inverse operations. I'd have to multiply both sides by 2. And that would cancel out because it becomes 1. So I would just have the y left by itself. So we're going to use the same concept. So I'm going to multiply by whatever the denominator is, because that's inverse operations. And then I'm left with whatever is in the numerator. So it's not really y. So we're going to go back and solve the actual problem now. So it's division by 2, so I would multiply both sides by 2. That's going to make that cancel out because it would become 1. 2 divided by 2 and multiplied by 2. And I'm left with just the numerator, which in this case is x plus 3. That whole thing is equal to 5 times 2 is 10. So just like down here we had just that numerator left, we have just that numerator, x plus 3, stay the same. We're just canceling out the denominator of 2. And then from there, we can just continue solving like normal. So I would minus 3 or subtract 3, and x equals 7. So we're going to do the same thing in the other example. This one is division by negative 3, so I'm going to do the inverse operation and multiply by negative 3 on both sides. That will make that cancel out because it will become 1. And I'm left with just the numerator, x minus 1 is equal to 6 times negative 3 is negative 18. And then I could again continue solving like normal. In this case, I need to add 1 to both sides, and x is equal to negative 17.